All right, we're going to talk about the second power rule, which is the negative power. So if I have a base that is raised to a negative exponent, in order to simplify our math problem, we're going to have to get rid of all negative exponents, okay? And I'm going to explain to you how getting rid of negatives work. So if I had 5 squared, in the first video we talked about that equaled 5 times 5, which is 25. 5 to the first would just be 5. We've already talked about how 5 to 0 power, anything to 0 power is 1. So as you can see, as the exponents get smaller, our answers also get smaller. So when we go to the next number in our exponent sequence, it'd be a negative 1. In order to get the exponent to be a positive, we're going to have to turn it into a fraction. And the way that we do that is if I take 5 to the negative first, I can turn it into a fraction by putting it over a 1. So in order to get rid of the negative, I have to flip the negative exponent to the opposite side of the fraction bar. So I get 1 over 5 to the first power, which is technically 1/5. So as you move from a 0 exponent into the negative exponent, our answers won't ever come out as a negative answer. However, they will get smaller and smaller because they are numbers located between 0 and 1. And 1/5 is smaller than 1, but greater than 0. So if I did 5 to the negative second power, right now it's on top of a fraction. So I would have to flip it to the bottom side and make it positive, so that I get 1/25 when 5 to the negative second power. So you can test that by punching that into your calculator, and you're going to get the same answer as a decimal. But if our base is a variable, we're not going to be able to punch it into the calculator, okay? So instead, we can take the same philosophy. If I make this into a fraction by putting it over 1, in order to get this negative exponent to become positive, since it's already on top, I got to flip it to the other side of the fraction bar. When I do that, the exponent becomes a positive exponent, and then I need the placeholder of 1. So our general rule for negative power is that we need to flip the base and the negative exponent to the opposite side of the fraction bar. When we do that, we're going to make the exponent positive. So for example, let's look at another one. I'll leave that definition up there. Let's look at another one. So if I have y to the negative 4th, I first have to make that into a fraction by putting it over 1. Since y to the negative 4th has a negative exponent, I need to move it to the opposite side of the fraction bar in order to make it positive. Since there is now nothing on top, I need to use a placeholder of 1. So y to the negative 4th is the same thing as 1 over y to the 4th. Let's look at another one that has the negative on the bottom. So if I had c to the fourth, x to the negative sixth. It's already a fraction. It's important to note that we only flip if we have a negative exponent. So since that c to the fourth has a positive exponent, it's going to stay on top. That's not going to move because it doesn't have a negative exponent. But since x to the negative sixth is negative, we have to put it on the opposite side of the fraction bar. So since it was on bottom before, it needs to move up here to the top in order to become positive. Then since I don't have anything on the bottom, I'm going to put a placeholder of 1. So my final answer is c to the fourth, x to the sixth over 1. Guys, if it is not a negative exponent, it is not going to move. All right, so let's look at a few. So again, just like in our zero power video, it's important to understand where the term separation is. Every single term is separated with a multiplication symbol. I find it easiest to walk through every problem and ask yourself if it is being raised to a negative exponent or not. If it's not being raised to a negative exponent, then it needs to stay on top if it started off on top, or on bottom if it started off on bottom. The only time we flip it is if the exponent is negative. So let's look at this one. So the first term is 5. Since 5 is not raised to a negative exponent, it's going to stay on top. I like to cross them out when I'm done with them. So then I'm going to go to the next term, x to the fourth power. Since that's not being raised to a negative exponent, it's going to stay on top as well. The next term is y to the negative fifth. Since it is raised to a negative exponent, it needs to go on the opposite side of the fraction bar and become positive. So it was on the top, it needs to go to the bottom in our answer. Then let's move to the bottom. So a to the sixth. That has a positive exponent, so it's going to stay on bottom where it already is. And then the last one is c to the negative second power. Since it's a negative and it's on bottom, we need to move it to the top to make it positive. So our final answer is 5x to the fourth, c to the second, over y to the fifth, a to the sixth. Let's do just a couple more. If it isn't already a fraction, remember you have to make it a fraction by putting it over 1. So I start off by making this problem so that it looks like a fraction. That makes it easier to see where those numbers and those variables are located in order to know where to move them to. So I'm going to start with the first term. So 6 is not being raised to a negative, so it's going to stay on top where it already is. X to the negative fourth has a negative exponent, so since it's on top, I need to move it to bottom in order to make it positive. Y to the negative sixth, it's a negative exponent, so I need to move it from the top to the bottom in order to make it positive. 1 was just a placeholder, so since I have something on top and I have something on bottom, I'm done with this problem. It's as simplified as it can get. All right, let's do a couple where we have the zero power thrown back in there. So if I have 5a to the negative 6 y to the 0 power. Remember, anything to the 0 power is going to become 1. So the first thing I'm going to do is put multiplication symbols in there, and I'm going to put it all over a 1. And then I'm going to walk through each term just like I did before. So 5 isn't raised to a negative power, so it's going to stay on top in my answer. A to the negative 6, so since it's raised to a negative power, it's going to go to the opposite side of the bar and become positive. And then y to the 0 power is going to cancel out, and that whole thing is going to become 1. Guys, it's important to put this multiplication symbol in between the 5 and the 1. If you fail to do that, your answer is going to look like 51 instead of 5 times 1. Since we know what 5 times 1 is, we can simplify that to just 5 over a to the 6th for our final answer. All right, and one last one. So if I have 3a to the 8th over 2y to the 0 power, I'm going to go through each term just like I did before. So 3 doesn't have a negative exponent, so it's going to stay on the top. A to the negative 8 has a negative exponent, so it's going to be flipped to the bottom in order to become positive. 2 doesn't have a negative exponent, so I'm going to put it in its same side. So I like to put the whole numbers out front. And then y to the 0 power is going to become 1. And since it was already on the bottom, it's going to stay on the bottom. The only thing that I need to do now is I can actually multiply 2 times 1 and reduce that to 2a to the 8th as my final answer. As always, if you need to stop it or go back to listen to something, if it was too fast for you, you can always rewind the video.